Hello students, welcome to my YouTube channel. In this video lecture, we are going to answer questions from Great Circles, Keith Williams Channel Navigation book. So let's start. A1. The angle between the true Great Circle track and the true Rumline track joining the following points at the place of departure is what? So the angle between true Great Circle track and Rumline track is called convergency angle. Points are 70 south, 160 west, 70 south, 179 east, pretty close to the anti-meridian. So let's draw this. Now what I'm going to do is I'm going to draw prime meridian, both prime meridian and anti-meridian on this diagram. So this is your prime meridian 0 degree. Let's consider this is the anti-meridian 180 degree of that prime meridian. 180 degree east, 180 degree west. So the first location is 70 south, 160 west. 160 west. And 179 east, like this. And the latitude is 70 south. 70 south means the great circle will pass to the nearest south pole. Okay. Now, so this is how it looks. Now we have to find convergency angle. Let's use convergency formula. D long in degrees into sine of latitude. Into sine of latitude. So 160 west and 179 east. Now pay attention. 179 east, and the difference between 179 east and 180 east is 1 degree. The difference between 160 west and 180 west is equal to 20 degrees. So total D long will be 21 degree. 20 plus 1, 21. Sine of latitude. So sine of 70. So sine 70 into 21 is 19 degree 44 minutes. Let's consider 20 degree. So convergency angle will be half of convergency. So half of 20, that is 10 degrees. Okay. So the angle between true great circle track and true Rumline track joining places alpha and bravo is 10 degree. Which of the following is true of all parallels of latitude? They are both rumlines and great circles. They are great circles but not rumlines. They are neither rumlines nor great circles. They are rumlines but not great circles. So they have asked us specifically about all the parallels of latitude, all latitudes including the equator. So delta is the right option. Now let's consider this is your Earth's surface. Okay, this is your equator 0 degree. Now this equator 0 degree is a unique case, as in it is both a rumline and a great circle. All other latitudes except the equator, okay, all other latitudes in the north, in the south are only and only rumlines because they run in fixed direction, either east or west. Okay, but they do not have the same center as that of the Earth's surface. And the radius of the earth, so they cannot be regarded as a great circle. Equator can be. Okay, so the only answer that is satisfactory here is delta, because all latitudes are rumlines, but all latitudes cannot be great circle except the equator. Okay, next. Aircraft departs from position A and flies northward along a meridian for 2,750 miles. After reaching that point, it flies west along the latitude for 400 miles. What is the coordinates? What are the new coordinates? So 9 degree 10 minutes south, 178 degree 22 minutes west. So again, so this is your prime meridian, let's say. This is your 180 degree anti-meridian. So 180 west this side, east here. 9 degree 10 minutes south. 78 degree 22 minutes west. Okay. Now from this location you are flying northwards for a distance of 2750 miles. Now when you are flying along a particular meridian, you are actually flying a great circle track. So this 2750 is nothing but your great circle distance, d lat in degrees into sine, correction, into 60. So 2750 divided by 60 equals to d lat. So 2750 divided by 60 is 45 degree 50 minutes. 45 degree 50 minutes. Okay. So your initial latitude is 9 degree 10 minutes south. Let's say there is this equatorial latitude here. Okay. Now your total difference is 45 degree 50 minutes. Now the difference between equatorial latitude and this 9 degree 10 minutes south latitude is equal to 9 degree 10 minutes. So this total 45 degree 50 minutes is going to get divided into two parts. First, 9 degree 10 minutes, and second, 45 degree 50 minutes minus 9 degree 10 minutes, which is equal to 36 degree 40 minutes. So that means you are going to travel 9 degree 10 minutes in the southern hemisphere up to the equator. From the equator you are going to travel extra remaining 36 degree 40 minutes. So your new latitude will be 36 degree 40 minutes north latitude. Now from this latitude you are traveling westwards for 400 miles, for 400 nautical miles. So when you travel along a particular latitude, you are actually traveling a Rammline distance. D long in minutes into cos of lat. So 400 divided by cos of 3640 equals to D long in minutes. So 400 divided by cos 36 degree 40 minutes. 498 degree 40, that is correction, 498 minutes is your answer. Now 498 minutes divided by 60 is 8 degree 18 minutes. That means your new longitude will be, now this initial longitude is what? 178 degree 22 minutes west. Okay. So new longitude will be in the eastern hemisphere. Okay, to the east of 180 degree anti-meridian. So now see, the difference between this 180 degree west meridian and this initial longitude 178 degree 22 minutes is how much? Is equal to 1 degree 38 minutes. Now out of this total d long of 8 degree 18 minutes, 1 degree 38 minutes will be traveled in the western hemisphere like this. At anti-meridian you are going to cross this anti-meridian, enter the eastern hemisphere. So remaining difference is 8 degree 18 minutes minus 1 degree 38 minutes, 6 degree 40 minutes. So you are going to travel extra remaining distance 6 degree 40 minutes in the eastern hemisphere. 6 degree 40 minutes. So your new longitude is 6 degree 40 minutes minus 180 degree. That is 173 degree 20 minutes east. Okay, this d long 6 degree 40 minutes, this difference you are subtracting from 180 east longitude. When you subtract that, you will be arriving at a longitude which is 173 degree 20 minutes. So what are the coordinates? Final coordinates are 36 degree 40 minutes north, 173 degree 20 minutes east. Next. A rhumb line is the shortest distance between two points on a polyconic projection. Any straight line on a Lambert's chart. A line convex to the nearest pole on a Mercator. A line on the surface of the earth which cuts all meridians at the same angle. So delta. By definition, a rhumb line is a line which crosses all meridians at the same angle. Alpha is given, Bravo is given. The average true course of the great circle is 100. What is the rhumb line? Very simple. So I have explained this before. A is here, B is here. So A is 55° north, B is 54° north. Longitudes are 00° prime meridian, 010° east meridian. So you are traveling from A to B. This will be your great circle. They are talking about average great circle. Now we all know that the track direction along a great circle will continuously change as you start from point A and arrive at point B. Contrary to this, the track direction along the rhumb line track remains the same. Start to end, A to B. Okay, so the average of this great circle, the average means the mean of something. So it will be somewhere here. Okay, the middle part. Now this point, the average of this great circle will be parallel to this rhumb line track. So the direction of this great circle will be equal to the direction of rhumb line track. So if average great circle, whenever they use the word average great circle, remember it's another term for rhumb line track. So if average great circle is 100, so this rhumb line will also be equal to 100. Okay. Aircraft passes position A and goes to position B. What will be the great circle track on departure from A? So your initial great circle track. So this. Okay. And you are in the north hemisphere, 75 north. This is your great circle. Now, this is A, this is B. Now, rhumb line track at A is equal to 270. This is your rhumb line track at A. Great circle track at A will be rhumb line track at A plus the convergency angle. So 270 plus this little convergency angle. So this entire thing will be your great circle. What is the convergency angle here? It is d long in degrees into sine of latitude. 120 west and 140° 30 minutes. So the difference is 20° 30 minutes sine of 75. Sine 75 into 20° 30 minutes is 19° 48 minutes. So convergency angle will be half of 19° 48 minutes, that is equal to 9° 54 minutes or approximately 10 degrees. So great circle track will be equal to 270 plus 10, that is 280 degrees. So great circle track at A is 280. Parallels of latitude except the equator are rhumb lines. Equator is one latitude which is both a great circle and a rhumb line. All other latitudes are only rhumb lines, not great circles. Next. North 48° 50 minutes, east 2° 16.5 minutes east. Now antipodes. Now remember, let's say this is your Earth's surface. I take one point here, like for example 50° north and 100° east. This point will be called pole, and the point directly opposite to it will be called antipode. So the coordinate of that antipodal point will be, if the latitude will be the same, the latitude value will be the same, hemisphere will change. So if it's 50 north, the antipodal point will be equal to 50 south, and longitude is 100 east. So the longitude of this point will be 180 minus 100, that is 80. 80° west, 080 west. Okay, make sure the sum of the longitudes is equal to 180 degree. And if this is eastern hemisphere, this will be in the west. Similarly here, now this point is 48 degree 50 minutes north. So the latitude value will remain the same. What will change is the hemisphere, south. This is eastern hemisphere. So what the longitude will be western, and the sum of the longitude should be 180 degree. So 180 minus 2 degree, 16.5 minutes. So that is equal to 177 degree 43 minutes. Okay, so this is the answer. On a Lambert chart, great circles which are not meridians are curves concave to the parallel of origin, straight lines regardless of distance, curves concave to the pole of projection, straight lines within the standard parallel. So concave means bending away from something, to bend away from something. So on a Lambert chart, great circles are curves which are concave to the parallel of origin. Let's say this is your Lambert's chart. These are the two standard parallels. Standard parallel number 1, standard parallel number 2, and there will be a parallel of origin in the center. Parallel of origin. Okay. So the great circle that you draw, if you draw a great circle which is to the north of this parallel of origin, it will bend away from it. If you draw a great circle on a track to the south of parallel of origin, the great circle will again bend away from it. Okay, so it's concave to the parallel of origin. Next, for a direct Mercator chart, a rhumb line is a curve convex to the equator. Convex means to bend towards something. Complex curves concave to the equator, curves concave to the pole, straight line. So on a Mercator chart, a rhumb line is always a straight line. Okay, so remember this. Remember all the properties of all the charts. Very easy. Remember the great circle properties, rhumb line properties, scale, convergency. That's it. With this, we'll stop here. I will do the next 10 questions in the next video lecture. If you have any questions, feedback, let me know in the comment box of this video. Thank you for your time. All the best.